Hey everyone, happy Monday. Hope, as always, that you're healthy and doing well and that your families are healthy and safe as well. Remember just to stay healthy. Yeah, don't do anything crazy. Try not to go out as often as you can. Just tough out the quarantine. So hang in there. We're all in this together. Um, just have another quick lesson today. A couple of announcements first. So just remember that the the quarter ends this Friday. So all the work, the policy is it has to be turned in Friday. So let's just say by midnight, all the work has to be due. So check if you have missing work, and if you do, please get it done. Please get it done by this Friday. Excuse me, I just ate. Sorry. So cool. And then yeah, in terms of just these lessons, right? So I'm just making these videos because in general, I miss just like teaching in person, like miss our classes and stuff. But you don't have to rely on these. So feel free to Google search all of these topics, and you can always watch like Khan Academy or other videos online to help explain these topics to you. Read your book, read whatever you need to. So don't feel like these videos have to be necessary. I just like doing them. Hopefully they're useful to you. So yeah, let me know if you have any feedback or if I can change things to make it better for you guys. And that's it. And then I think at the end of this, the only other thing I'm interested in is at the end of this video, I'm going to ask you to comment below. So just comment below and say if you specifically, about IXL and written homework. So between those two, which one do you like more, or what your thoughts are on IXL or written homework? I kind of want to stick to one. IXL is a lot easier, I think, and you also get the answers right away. So I'm leaning towards that, but let me know what your thoughts are. And obviously you probably don't like either, but other than not wanting to do any work at all, let me know which one is better for you guys to do at home. Anyway, so before we get started, I do want to just show you this this post real quick. So here's an Instagram post I saw yesterday. This is a picture of Albert Camus. He's an author, a really good author. He wrote The Stranger and the play. You should definitely read The Stranger if you haven't already. Great book. Anyway, so this is a post very appropriate for these times and relatable to today. This is a quote from him. It says, "My dear, in the midst of hate, I found there was within me an invincible love. In the midst of tears, I found there was within me an invincible smile. In the midst of chaos, I found there was within me an invincible calm. I realized through it all that in the midst of winter, I found there was within me an invincible summer, and that makes me happy, for it says that no matter how hard the world pushes against me, within me there's something stronger, something better, pushing right back. Truly yours, Albert Camus." So yeah, I love this. Albert Camus, great author, and just very appropriate quote for what everyone's going through right now. So and also in general, just for life in general. So hang in there. We're all in this together. This will definitely end soon. So whatever you're feeling right now, just know that it'll end soon and it'll get better, and that you have it within you to change something, sad and negative into something positive. So anyway, all right, let's do this. So let me get my camera back. So here's our new topic. It's called rational expressions, and we're going to specifically be multiplying and dividing them. Rational expressions, if you don't know, there's just a quick definition here. It's just a polynomial divided by another polynomial, right? So typically, you just think of fraction, right? But with fractions, they're typically just numbers. So for this chapter, we're mostly going to be dealing with fractions, but instead the numerator and denominator are going to be polynomials. So they will have variables, which will make things a little bit more complicated. But just like with fractions, the goal is to simplify them, right? And get them to be the most simple possible, especially when we multiply and divide them. So you'll see kind of the comparison. But just think fractions, but now we have to use variables and your skills that you learned with polynomials from chapter 6 and with quadratics from chapter 5, I think. So I broke down the skills just real quick. The skills you're going to need for this chapter, for this topic, really. You do need to remember your factoring again. That's just been a constant theme throughout. So yeah, just remind yourself of the factoring rules. Exponent rules, of course, that should be natural to you by now, hopefully. And then, of course, multiplication, division, and addition and subtraction. So, duh. So that's that. So let's just do a quick example. This doesn't require much arithmetic. It's just seeing an expression and simplifying it. So again, the goal is to simplify, right? So we start out with 12x to the 7th divided by 4x to the 4th. As you can see, both are polynomials, right? They're just one term, though, so it's very simple for us. Just one term polynomials. But we still have to simplify. And so the way I look at this, right, is I combine the like things. Like I look at what is similar, right? I've got a number here and a number here, so maybe those two things I can simplify, and it turns out, of course, I can, right? 12 and 4, I box those out here because I can simplify this to be 3, right? So the 12 and 4 are being divided by each other, so I can simplify that to be 3 eventually. And then here's where your exponent rules come in, because I have x to the 7th over x to the 4th. And with your exponent rules, of course, if you have the same base and they're being divided by each other, you're just going to subtract the exponents. So I have 7 on top, 4 on bottom. That means that I'm going to be left with 7 minus 4, which is 3. And so that's the work here. The 12 and 4 become 3. X to the 7th, x to the 4th becomes, as you can see here, x cubed. So the final answer is 3x cubed right here. And the last thing here is x can't equal 0. And so where that comes from is, so the other part of this is because we're dealing with fractions and we have variables. The other part of this is looking at, okay, well, we want to avoid the number one rule, right? And the number one rule is we can't divide by 0. So if you look at this fraction, right, here's a fraction. I still need to be careful about dividing by 0 because x this bottom part could be 0. Who knows, right? And so if you look at it, well, this bottom part is only 0 if x itself is 0, because 0 times 4 would be 0, right? Excuse me. So that's the only restriction here. We have to say here x can't equal 0 because because if it does, then this whole denominator equals 0, and we don't want that, right? So that's the last part right there. That's it. All right. Next example. So this is going to require some factoring, right? So let's look. I've got a quadratic over a quadratic. So in this case, you're pretty much going to follow the routine, right? And the first step is to always factor when you see expressions like this. This first example, we had nothing to factor, right? We could just go straight into the crossing out and the simplifying. But for this, we have to factor, okay? So we're going to take the top and we're going to factor that and take the bottom, factor that separately. And that's what I did here. If you look at this section here, x squared minus 2x minus 3. Remember, it's a quadratic, so we factor by multiplying the a and c term, -3. Two numbers that multiply to -3 add to -2 will be -3 and +1. So I have x minus 3 here and x plus 1 here. That's the numerator. It's the top part. The bottom part, x squared plus 5x plus 4. I have a times c is 4. So two numbers that multiply to 4 and add to 5 are 4 and 1. So I have x plus 4 here, x plus 1 here. So I factor both. That was the first step. Now let's rewrite and start to cross things out. So that's always the second step, right? Again, so sometimes you don't have to factor and you can go straight to this step. But if you do have to factor, you do that first and then you start to rewrite it and cross it out. And so I'm going to rewrite the top as x minus 3x plus 1 because that was this quadratic, right? You're going to rewrite the bottom, x squared plus 5x plus 4, as x plus 4x plus 1. And now you can see where you cancel things out. So I've got x plus 1 on top, x plus 1 on bottom. Of course, those cancel out, and you are left with x minus 3 and x, that should be plus 4. So we're going to change that to +4, okay? Yeah, 1 sec, +4. There we go. All right, so sorry for that mistake, but x minus 3x plus 4, that's the final answer, right? So that's all we were left with, so that's the final answer. And this part, again, we have to figure out, okay, are there any restrictions to x, right? So can the denominator equal 0? Well, this was the denominator, right? This part right here, right? This was the denominator. So if this denominator factors to x plus 4, x plus 1, when could that equal 0? Well, if x is -4 and x is -1, then it equals 0, and that's not good, right? So you basically are just looking at the solutions to these, and now you're saying, well, it can't equal those, otherwise you're going to divide by 0. So hopefully this makes sense. You won't see this too often. Some problems will ask you for that. Some multiple choice questions will just say, okay, what are the restrictions? And then you can just look at the denominator and say, well, here, if I have -4 or -1, then that's not okay because I can't have 0. All right, so that's that. So let's do some, add some more action to it. So this was an actual multiplication problem now here, right? So I've got actually 2 rational expressions. Here are 2 polynomials in an expression, and here are 2 polynomials in an expression. All I have to do now is just multiply and combine them, right? So the first step is, again, to factor. And you take it slow if you need to. X plus 2 you can't factor, so I rewrote it. 3x plus 12 you can factor by taking out the 3, and then you're left with x plus 4. Cool. Next one, x plus 4 cannot be factored, so left that there. X squared minus 4 is a difference of squares, so I factor that to x plus 2 and x minus 2. Okay, so that's that. And now we go to the second step, which is, of course, to cross things out. And so now with this, right, so you can cross things out that are top and bottom, of course, because that's in a fraction. And then remember, you can also cross things out that are diagonal from each other, right? Because now you're trying to combine these because there's a multiplication symbol. So you can cross out things that are diagonal from each other. Well, this is really nice because I had an x plus 2 up here and then an x plus 2 down here, which are diagonal. So I'm going to cross those out, as you see here, right? And then I had an x plus 4 at the top here, and diagonal from it, I had an x plus 4 here. So those will cancel out. So as you can see here, I crossed out all the things that I saw twice. And as you can see, the top, the numerator completely cancel out, right? And that doesn't mean it's 0. That makes no sense, right? It can't be 0 because we're multiplying and dividing. So if it can't be, it's not 0, right? If it all cancels out on the top, you're left with 1. So the top is 1 now. And then we multiply whatever's left in the bottom, which was the 3, which is still there, and the x minus 2, which is still there. So the bottom is just 3 times x minus 2. So that's the final answer. 1, because there was nothing left at the top, and then 3 times x minus 2. And that's it. Cool. And then last example here, we'll do one more, and this is division now. So you're going to do the same rules, except there's one step you do first, right? And when you see a division symbol here, right, you have to turn it into multiplication, just like with regular fractions. And remember, to do that, you have to turn this to multiplication, and the way you do that is you flip the one you're dividing by, the second expression or fraction, right? Because dividing by a fraction is the same thing as multiplying by its reciprocal, right? So here's the first step. I rewrite my first expression, which is still there. I'm changing this to multiplication. And to do that, I had to flip this. So it was 16 over 9y to the 5th. And now I'm multiplying by 9y to the 5th over 16. And so now we can follow the steps. It turns out, right, there's nothing to factor here. So I wrote that. There's nothing to factor. So we can just cross out, go to that second step right away, where we just cross out and simplify. So let's look at this real quick, right? I'm looking for diagonals and then also things, on levels of each other on top and bottom. So I've got a 4 here. Diagonal from it is a 16. So that's going to cancel, right? This 4 is going to go away, turn to 1. And this 16 is going to change to a 4, right? So that's how those cancel. Diagonal, I also have a 9 and a 9, so that's going to go away completely, right? And that's it for the numbers, right? So that was it for the numbers. Now we look at the variables. I have x cubed here. There are no x's diagonal, so that's fine, but I have an x squared below it. So this is going to turn out just to be a simple cancel with the exponent rule, where if I have 3 x's on top, 2 at the bottom, I'm left with 1 at the top, right? Because 3 minus 2 is positive 1. So 1 is going to stay at the top. And now with the y's, they're diagonal from each other. So it's just going to follow the same thing. I have 5 y's here, and I'm canceling out one of them here. So 5 minus one of them is going to be 4. So there's going to be 4 y's left. And all the work for that is right here, right? So I first did the numbers, right? The 4 goes away, the 16 changes to a 4, and the 9s go away. And now we're left with just the variables. And this 4 is going to stay here, right? The 16 changed to a 4. So I'm left with the variables, and like I said, 3 x's on top, 2 at the bottom, 1 is going to be left at the top, and then I have a y down here diagonally, and 5 y's up here diagonally, so 4 of them are going to be left. So I rewrite that again. X, I was left with x on this side, and there was nothing left at the bottom. Here I was left with y to the 4th, and the 4, of course, stays. And you just combine those. You just multiply straight, right, to combine it. And I'm left with x, y to the 4th, divided by 4. And that's your final answer. And that's it. So hopefully that makes sense, right? So look at your book if you need to. Again, search up any videos that you need. I'll post the assignment. It'll be due on Thursday, and then that's pretty much it for this week, just those 2 assignments. Don't forget about your homework due tomorrow. Thank you to all of those who have turned that in, and thank you to everyone for doing that IXL, that first IXL assignment right away. So don't forget to turn in your homework tomorrow. That's from the book. Just take a picture and email it to me. And if you're having trouble with that, just let me know. And then I'll post a homework that'll be due Thursday night. And yeah, and that's it. Again, let me know if you have any questions. Always feel free to reach out. I'm like not doing anything, right? So we're all just staying home. So there's plenty of time to help out. And then again, don't forget to comment below, and just if you have any thoughts about IXL or written homework, if you really strongly prefer one or the other, just let me know. And that's that. Thanks, guys. Hope everything goes well.